All right, so my name is Jake Carenti. Thank you all for coming to my final presentation, and I'll be talking about my project, which was improving Podman Machine. So here's just a quick itinerary for the talk. First, I'll go over a little bit about myself. What are containers? What is Podman and Podman Machine? What do I mean by improving Podman Machine? Why do we want to improve it? What are some goals for the project? Some other Podman work that I did. How can you help me? And then I'll just finish up with a closing. So, like I said, my name is Jake. I'm currently a student at UMass Lowell studying computer science. Where in the fall I'll be a senior. I'm from a very small town in Massachusetts called West Newbury, which is on the border of New Hampshire. This is my second summer working on the container runtimes team. And in my free time, I enjoy running, cycling, and fishing. So what exactly are containers? Well, at its core, a container is just a constrained Linux process that's isolated from the rest of the system. So containers utilize existing Linux functionality to actually achieve this isolation. And one of these tools would be cgroups, which actually allows us to limit how many resources a container can use. So for example, we can actually limit the process or a group of processes from completely dominating a system's resources. So on the other hand, we have names. And this means that we can have one process see certain resources on the system and have another process see completely different resources. And one example of a namespace would be the PID from seeing any processes outside of its running process. So next are some security tools that can actually be found within the Linux kernel that containers take advantage of. So the first one would be SELinux, which actually allows us to define what access a process has to the file system. We have seccomp, which allows us to make specific system calls either available or not available to a given process or group of processes. Or root, divided into individual capabilities, which we can actually enable or disable for a given process. So now we know what a container is, but how does this tie into Podman? Well, Podman is an open source project that's available on most Linux platforms, and it's a daemonless container engine for developing, managing, and running your OCI containers and container images on your Linux system. So Podman provides a Docker-compatible API that also allows you to have remote applications launch containers. So the big selling point with Podman here versus Docker is it can be run as rootless or rootless by default. So, just a quick recap. Containers at their very core are just Linux processes, and Podman is a way to manage those containers. However, we run into an issue if we want to run containers on a non-Linux machine, such as Windows or Mac OS. And how exactly would we go about running a container on Windows, for example? Well, Podman handles this scenario by running a Linux virtual machine on your host, virtual machine. And we call this set of subcommands Podman machine. So my role for the summer was to aid the team in adding features and fixing bugs, especially within the domain of Podman machine. And as I'll talk about later, this included tasks like adding a console mode to Mac OS, initiating a machine refactor, and then also handling other Podman work that's unrelated to machine. So what exactly is the importance of improving Podman? To improve this summer is ensuring that the Podman experience is uniform across different devices, because we support Podman on Linux, Windows, and Mac OS. And occasionally, there are some discrepancies between them and their implementations, which definitely isn't ideal for their user experience. Another significant issue that I tried to improve this summer is the code organization and usability of the project. When describing this issue to me in a meeting at the very beginning of the summer, my mentor, Brent, he phrased it that Podman machine feels like a glorified script. So in comparison to the previous issue, this doesn't affect the user per se, but rather the developer and the developer experience. And on top issues, I tried to help the team reduce the issue count on GitHub. With Podman's significant gain in popularity, especially with the recent release of Podman Desktop, there have been a massive abundance of issues reported, and the core team had previously defined a threshold, which was around 200, that they wanted to stay under, and our current issue count is over double that, and even almost kissed 500 at one point. So to make all of the improvements I mentioned previously, it can be broken down into three. The first being add a console mode to Podman machine on macOS. Second would be to initiate a refactor for a Podman machine. And third, work on other Podman related tasks. So like I said, the first goal of the summer was to get console mode working on macOS. And this goal stemmed from a discrepancy in Podman machine's behavior on Linux and macOS. So by default, when you run the command podman machine start, it does a quiet boot of the virtual machine. And for some, this may be exactly what you want. But for others, this is absolutely not ideal, because if something were to go wrong during boot, you're not going to get any feedback on what's going on. So on a Linux machine, if you were to set the log level to debug using the log level flag, and then do a machine start, you'll get a graphics window pop up and display all the boot information as the virtual machine is starting. Mac, however, you're going to get completely different behavior because nothing's going to pop up at all. So under the hood of Podman machine, we actually utilize a library called VFKit. And VFKit provides a command line tool that allows us to use Apple's hypervisor virtualization framework to create a virtual machine. And to add a console window to VFKit, I had to make modifications to the code to allow the user to specify VirtIO GPU and VirtIO input devices as actual inputs to the command line tool. So by VirtIO GPU device, I mean something like the display, and by VirtIO input device, I mean something like your keyboard or your mouse. So I also needed to create a flag the user could use when they wanted a graphical interface. And when the user specified this flag, it would actually start the graphical window when it was set. So after I got the PR merged into VFKit, I was actually able to get another PR merge for Podman to tie all the functionality together. So this is just a quick screenshot of what that pop-up window looks like when you use the debug log level and then do a Podman machine start. So you can see all the boot info right in front of you. So like I said, also the second goal of the summer was to initiate a refactor for Podman machine. So you might be asking, why do we need to refactor the code for Podman machine at all? Well, like my mentor Brent said, it's essentially a glorified script with lots of duplicate and unorganized code. And this stems from the fact that it was just implemented fast. And a refactor, as you all know, is a fairly large task. So coming along with it comes large and a lot of parts. So in the beginning, I had the chance to look through the Podman machine code to kind of figure out what exactly could be refactored. And I took a week to go through that, and I met with Brent to go over what I found. So the subtasks listed here for the refactor come from that conversation and research. So I started off with creating a more systematic implementation for the hypervisors that we support. We currently support 4 different virtualization providers: QEMU, Apple Hypervisor, Hyper-V, and WSL. Each hypervisor has to implement a few different interfaces, but the important ones for you to know are the virt provider interface and the VM interface. So the VM interface actually defines a virtual machine's basic operations. So, init, inspect, start, stop, etc. The virt provider interface, on the other hand, defines specific behaviors and attributes of a virtualization provider. So this includes providing the compression format, your image format, functionality to list images, or machine, create a new machine, etc. So, however, different virtualization providers put these implementations in different spots in the code base, which made knowing where to look for certain things pretty difficult. So I decided to be explicit about where these specific interface implementations should be located. So each hypervisor implementation has at least 2 files, a config.go file and a machine.go file. And previously, it was kind of a toss-up whether the virtual machine interface was fully implemented in either machine, config.go, or honestly a mix of both. Sometimes that happened. So I decided to dedicate the config.go file for implementing the virt provider interface, and machine.go is responsible for implementing the VM interface. I also worked on breaking up large functions into reusable components. So across the different hypervisor implementations, there were functions that were hundreds of lines long, which is just not maintainable or easy to read. So I set out to identify chunks of code that could be turned into their own functions, especially within the VM interface implementations. And I was able to do this for each hypervisor implementation across multiple files with pretty decent success. And that work was actually spread out across 5 different PRs on GitHub. Additionally, not only were there incredibly large functions, but there were also functions that were copied from one hypervisor implementation to another, specifically without changing any of the function or parameter names when doing so. So, for example, there were functions in the Hyper-V implementation that were named after Apple hypervisor functions, which was incredibly confusing. So, although this was a fairly simple fix, it had drastically reduced confusion when trying to understand the code for the first time. I also worked on deprecating some unsupported code for one of the original hypervisor implementations. So under the hood for the QEMU implementation, we actually modified the underlying structure for how we represented the virtual machine. And this change was done over a year ago, so it was time to no longer support the legacy structure. And although this change was done a long time ago, and most users have absolutely no chance of being affected, there's still the chance of introducing a significant breaking change. Specifically, the current implementation works so that if we see the users using an old machine structure, we migrate it to the new one. However, if I was to remove the legacy code, that migration can't happen. And if the migration can happen, then the user won't be able to remove the machine that's using the legacy structure, and will have to manually find the files associated with that machine in their file system and manually delete them. So because of this breaking change, there's a running discussion regarding when exactly should we merge these changes into upstream. But regardless, there's been a PR open on GitHub for the fix. Another section of the refactor that I've been working on was an initial pass at removing some severe duplication that was found in the machine area of the code. So if you were to go through each of the hypervisor implementations, you would notice that some of the code was the same across them. And this could be an entire function or just smaller chunks within them. So regardless, duplicate code was present, which is never good for maintainability. My earlier task of breaking up the larger functions actually aided in the effort to identify code that could be reused. So in the initial pass, I was actually able to consolidate over 200 lines of code just in the different machine.go files. So up to this point in the list, all of these tasks have been completed and are present in upstream Podman. However, there's some in-progress tasks still going on, and one of these would be documenting a standard on how to implement a new hypervisor. So this is essentially a recipe for how someone would go about adding another hypervisor that Podman machine will support. For example, it describes, for this hypervisor, it gets implemented this way. There's an interface located here and here that needs to get implemented, and it needs these end functions. You have to set this up first, then X, then Y, then Z. So the goal with this is to clearly define a process and structure in which these hypervisors are implemented, both new and old. There are some other tasks remaining for the Podman machine refactor as well, specifically finding a design pattern to create new hypervisor instances within the code. So we believe that there can be a more efficient way to write some of the code for the different hypervisor types. Additionally, we would like to increase test coverage across the different hypervisors. So, this is proving to be a top priority for the team in the next quarter. Especially, we're going to be focused on getting CI working properly. Finally, throughout the refactor, it's becoming abundantly clear that we need more documentation for the code that already exists. So this is another aspect that needs to be addressed. However, there was overall good progress that was made towards making machine more maintainable and readable. So here we have the initial results from the refactor. So if you were to compare how long the original functions were before the refactor, you would see around a 40% decrease in their length. However, in an attempt to make the code more readable and maintainable, it required roughly a 3.5% increase in the lines of code across the machine directory. So although I was assigned an intern project, I'm still responsible for tending to internal and external stakeholder needs, whether this be a customer or the community. So therefore, alongside my other goals for the summer, I've also been completing additional non-Podman machine tasks. And I think that's where kind of my role differs from other research interns. I'm not necessarily working on a research project. I'm working on an upstream product with a fairly large community behind it. So in the list here, we have the first two PRs, and they deal with the Podman volume subcommand. And the first one adds additional filter support when listing Podman's volumes and also when cleaning up dangling volumes with Podman prune. PR 19629 fixes an issue where the logic for listing volumes with multiple filter options was wrong. So rather than listing volumes that matched all of the labels that the user provided, it would actually list volumes that matched with absolutely any of them. And this isn't Docker compatible, so obviously that was a necessary fix. PRs 19211, 19208, and 19102 are a series of PRs that implemented a customer feature request. So the customer went on Bugzilla and stated that they were using Podman kube play and Podman kube generate, and they wanted to use annotations in their kube YAML that was longer than 63 characters. Now in Podman, we trim these annotations that are longer than 63 characters so we can maintain support with Kubernetes. However, to get around this, I actually added a flag to opt into maintaining the length of the annotation for Podman kube generate. This also required adding a flag to Podman kube play to specify that we actually want to use a YAML with long annotations, knowing that it won't be compatible with Kubernetes at that point. Podman actually has annotations that, by default, are not included in the generated kube YAML file when you do the command Podman kube generate. So, however, the customer also wanted to see that these reserved annotations were in their generated file. So this also required me adding a flag to add these reserved annotations to the generated file and also add the backend support for the annotations in Podman kube play. So all of the PRs listed above have been merged into upstream Podman, and the customer RFE will also be making its next RHEL release. Finally, I have listed two issues that I was recently assigned to work on. The first is an issue where Podman kube play doesn't actually expand environment variables like Kubernetes does, which means Kubernetes compat is broken for that functionality. Additionally, there's an issue where having certain filters for prune actually have the incorrect logic. So with that said, what exactly can you do to help the container runtimes team out? Well, simply put, you can contribute. I encourage you all to head over to our GitHub, go to the Issues tab, search for the Good First Issue label, or find any low-hanging fruit you're comfortable with, and open up a PR. If you want to get more involved in the Podman community, I also feel free to join our Slack channel or IRC. There are also Podman community meetings if you'd like to have a chance to ask Podman maintainers questions or address any concerns directly. We actually have community meetings on the first Tuesday of every even month, and a community cabal on the third Thursday of every month. So if you don't know, a community meeting will consist of demos, and a cabal will consist of planning and discussion of future changes. So with all that said, I just want to give a massive thank you to Heidi and Jen for putting together a great internship program this summer. You're both incredibly supportive and did an amazing job. I also want to thank my mentor, Brent. I know you're a very busy man and don't typically take interns, but you're incredibly supportive of me. You gave me the honest feedback that I'd asked of you, and you gave me some really fun things to work on. So finally, I also just want to thank the rest of the Container Runtimes team for taking me in for the second summer in a row. You know, everyone's always a pleasure to work with, and I always learn a lot from everyone on the team. I also do want to just mention that I've unfortunately not made significant progress on rebuilding the NERC test cluster. The work for my primary internship progress ramped up quite quickly, and I actually needed to prioritize that. So with that, I'd be happy to yield any questions. I know I saw some in the chat, but.
Yeah, so I put some in the chat. I don't know if you want me to repeat them or not.
No, I can repeat them. So your first one is, why are there 4 hypervisors for Podman versus 2 or 6? It comes down to wanting native support on those operating systems. So at first we had QEMU, and that currently works in all operating systems, but we want native functionality and we have Apple Hypervisor for Apple. We have WSL and Hyper-V for Windows.
Okay.
Hopefully that answers your question.
Yeah, I was confused because you had mentioned 3 operating systems and 4 hypervisors, so now I get it.
Yep.
And so the work that you did to add more with a design pattern is basically on the assumption that there might be new things that come along that people want to use Podman with different hypervisors because someone will come out with a new hypervisor that's better, or because you'll want to do different operating systems.
Yeah, well, for one example, Chris Tate during the midterm presentation asked if we're planning on adding any more support for devices like maybe a Raspberry Pi.
Right.
So if it's not a priority right now for the team, but if it was in the future, having some sort of documentation and process outlined for adding something like that is important.
Cool. And do you think that that's the scope of something that could be a future intern project, or do you think it's too complex for something like that?
I think at this rate, with how things are going with Apple Hypervisor and Hyper-V, it's a fairly complicated implementation. It requires a lot of moving pieces with other teams and projects.
Yep, that's what I thought.
Having, a good time on his own trying to get these working. So I think to play it safe,
Chris
I would say
always
it's
has a
not
good time
yeah.
with things like that.
Mm-hmm. So I would say play it safe, and it's not a great internship project. But I think Brent would probably have a better opinion on that. And then your next question was, why did the customer want to see all the long annotations? If I'm being honest, that wasn't made clear. On the Bugzilla, there was no description, so I had to go through a colleague to get the customer description. So I kind of just got the summary out of it. So unfortunately, I can't answer that question.
I thought maybe you talked to them directly.
No, I didn't know direct contact with customers.
It would be okay. A lot of times we don't get any direct contact with customers, especially in the research group. So it's interesting to hear when people have the chance to do that.
Any other questions?